For a number of weeks now, work at thehackerworkshop.com has proceeded to bring perfection to the crudely conceived idea of a real-time web-based action game that is not only running on unfamiliar and undocumented hardware, but is also conceived, designed, built, tested, and publicly exhibited in a ridiculously short time period. Such a game is Encabulation. Now really, the only new principle involved is that instead of hosting a web server on the internet with the unpredictable latency inherent in such a global scale transmission control protocol network, a dedicated Wi-Fi hotspot is instead embedded within the Encabulator hub itself. In addition to the aforementioned dedicated Wi-Fi hotspot, the Encabulation hub hosts a Raspberry Pi, a scavenged ATX computer power supply, and the requisite TurBULL encabulator board. Bits and pieces from SparkFun and Adafruit bind the whole project together. While the hardware of course is impressive, the real magic of Encabulation lies within its embedded software. The main game engine is written in the C programming language. C was chosen for its difficulty to use, the ease with which fatal programming mistakes can be made, and our team's general unfamiliarity with the language. As a result, our code quality closely resembles the output of a trained monkey after a night of binge drinking. Our code does deliberately violate the programmer's first law of multi-threading, which means that not only did we have to deal with the intricate issues of thread synchronization, but we also had to deal with the subtle bugs caused by race conditions that are almost impossible to debug. The user interface consists of a series of PHP-coded web pages. The front-end PHP code communicates with the back-end C game engine through the open-source Apache Thrift RPC framework. The game is played on a smartphone, a tablet, or other portable Wi-Fi connected device. At the beginning of the game, each player is randomly assigned to one of the 4 ding alarms that extend radially from the Encabulator hub. Each ding alarm, constructed of prefabulated amulite and secured to the Encabulator hub with a hydrocoptic Marzl vane, is fitted with 3 strips of LED lighting. The 2 strips on either side of the central strip are known as the gutter lights. These lights will flash red when points are deducted from a player's score. Conversely, the lights will of course flash green when points are awarded to a player. The central strip consists of individually addressable RGB LED pixels. These pixels are used to indicate the travel of the game ball during gameplay. When a game is not in session, the lights flash in an attract mode pattern, as you can see here. The end of each ding alarm is fitted with an ambifacient lunar wane shaft, ensuring that the arm is immune to the effects of sinusoidal repleneration. The attract mode pattern is used to draw players into the game. Players are held in a pre-game lobby until 4 players have joined the game. When the 4th player joins the game, each player is assigned both a ding alarm and a color. Players are notified of their assigned colors and ding alarms in the web interface. Players are then asked to stand at the end of their assigned ding alarm and click a ready button in the web interface to indicate that they are ready to play the game. When all 4 players are ready, the game begins when the Encabulator hub launches a game ball down one of the 4 ding alarms. The player standing at the end of that ding alarm must click the bounce button in his or her web interface to bounce the game ball back towards the Encabulator hub, where it will then be launched down another player's ding alarm. Points are awarded for successfully bouncing the game ball back to the Encabulator hub. Points are deducted from any player who allows the game ball to fall off the end of his or her assigned ding alarm. Points are also deducted for clicking the bounce button when the game ball is not on that player's assigned ding alarm. This prevents a crude form of cheating. Color is also used to increase richness and strategery in gameplay. The game ball will always be the same as one of the 4 players' assigned colors. Whenever the game ball is bounced, the player whose color matches the game ball color loses points. Therefore, players are motivated to ensure the game ball is not their assigned color. This is accomplished by clicking the Change Color button in the user interface. Points are awarded for successfully changing the game ball's color. Points are deducted from any player who clicks the Change Color button when the game ball does not match his or her assigned color. Unfortunately, the encabulation game was not able to meet all of its design goals. While the Raspberry Pi does in fact drive the TurBULL encabulator board as intended, there are serious performance issues on both Android and iOS platforms that we were not able to overcome by the project deadline. Nevertheless, we do believe that we have created something awesome with interactive lighting and should be entitled to a spot at the Red Bull Creation Contest 2013 Finals in New York City. For more information about the encabulation game, please visit www.thehackerworkshop.com and click on the projects link.